Alright, this is our second video for one-dimensional motion. We're going to start to add a couple more things in as our equations get a little bit more complicated, and the ideas that we're trying to solve for are going to do the same. Alright, before we get started, we have to learn what is the difference between a vector and a scalar. This is going to be a reoccurring theme throughout the year, so we have to make sure that we understand what the difference is and how it's applicable to this class. A scalar just has magnitude. It'll only tell you a speed, like 40 meters per second, or your weight in kilograms, say like 80 kilograms. That's a scalar. It only has one value. The magnitude just means how much in terms of a numeric value. A vector has both magnitude and direction. So like 40 meters per second headed south. Now I have more information about which direction I'm going and how fast I'm traveling in. This becomes more and more important as we start to get forward in other ideas like momentum, and we'll have opposing vectors or vectors that are going in the same way, and we need to know whether or not to add or subtract them. And we're going to use that today when we start to deal with more complex problems in dealing with displacement from my origin and whether or not to add or subtract an acceleration value. Alright, so let's see if we can start to solve some of these problems. We're going to start off with an easier one. So what is your displacement from your starting position if you accelerate from rest at a constant rate of 4 meters per second for a total of 5 seconds? Alright, your favorite equation in physics is x equals 1/2 at squared. This is going to be the equation that we are using all the way until May. If you don't know how to solve it, try this out. This is your first go-to. So x is your position, and it's going to tell you where your position is if you're starting from rest, as long as you're accelerating away. So if you're moving, if you know distance and you know acceleration, this is your go-to. All right, so x is what we're looking to solve for, so we don't have to rearrange anything algebraically. It knows our acceleration is 4 meters per second squared, and for a total of 5 seconds. So 1/2, I'm going in the positive direction, so 4 meters per second squared for 5 seconds. Now don't forget to square the time. That's very important because you'll get a wrong answer. So half of 4 is 2. 2 times 25 is going to be 50 meters as our answer. So our displacement is 50 meters from our starting position. All right, not too hard and all. Let's look at a little more complicated one. All right, what is the final displacement of a car that starts out traveling at 40 meters per second and then slows down to 20 meters per second in a total of 10 seconds? All right, this is a two-step problem because first we have to solve for the acceleration or deceleration rate of the car in order to solve the rest of it. So in the last video, we learned that average acceleration is the change in velocity divided by the change in time. So it's my final velocity minus my initial divided by my time interval. So 20 divided by 40 gives me negative 20 over 10 equals negative 2 meters per second squared. That negative value is very important because we need to know that we're slowing down. All right, that was our first step. So we solve for the acceleration. Now, the equation that we just learned, x equals 1/2 at squared, comes from a larger equation. X equals x naught plus v naught t plus 1/2 at squared. All right, that is the big equation. A lot of the times we're going to be taking things out of that. Like here, I'm going to say that I'm starting from rest, so this guy's just going to go to 0. So he goes away altogether. So now I know my initial velocity, v naught. What is the final displacement for a car that starts at 40 meters per second? It's always a good idea to write your variables over here. So v naught equals 40 meters per second. V final, even though we already used it, was 20 meters per second. Acceleration is negative 2 meters per second squared. And our last one, time, is equal to 10 seconds. So now I can just plug and chug the values that I have. My initial velocity is 40. my time is 10 plus 1/2. Now here's the important part in between a vector value. Because acceleration is negative, I want to put a -2 meters per second squared in there. And then time, again, is 10 seconds. Don't forget to square time. So 40 times 10 is going to be 400. Now, 10 squared is going to be 100. And half of 2 would be 1. But since it has a negative value in here, this whole guy turns out to be negative 100 when all the math is done. So 400 minus 100 equals 300 meters. And that's how you look to solve. So for this video, we're all good. And when you're thinking about getting your first fast car, don't let it be a Mustang.